Time. There we go. Good evening and welcome to the Code Connector Meetup for the fourth Tuesday of March. Every fourth Tuesday we have probably our main meetup of the month. And it's always either a feature speaker or a variety of speakers. So tonight we have one feature speaker to share with you all tonight. Once he starts speaking, please be sure you're on mute. That way the recording will stay focused on their frame and it'll show up better for the video. But for now, thanks for coming out. I think these are all familiar names, but of course, this is Code Connector. We're a tech meetup group, generally based out of Memphis, but we do have people who interact with us throughout the country and sometimes throughout the world. We love helping people and exchanging ideas with people in their various parts of their tech career, with an especially intentional focus on adults making career transitions, adults who are doing self-taught route, bootcamp route, things like that. That's kind of our sweet spot, but we do welcome people from all walks of life. We have tons of folks who went the traditional college route and things of that nature. So pretty much wherever you fall in tech, you'll be welcome here. As always, we have a Slack channel, which is our main place where we communicate on a daily basis. I'm going to put the invite to that right now in the chat. But I think all of you are already in, but just in case, we do have the invite to our Slack. Love for you to join us. Love for you to take place in the daily conversations. I'm just kind of looking at the calendar. Of course, this is March 28th. Again, glad to see you here. April is right around the corner. Hold on one second. Somebody else is coming in. Hold on one second. Let their audio connect. So, of course, yeah, April is right around the corner. So that being said, this Saturday, April 1st, we will have our Code Share Meetup. So tonight we have a featured speaker. On Saturday, it will be anybody who has code to share or even a design to share. We would love to see it. Kind of show and tell for code. So that'll be this Saturday the 1st at 1 p.m. Central. Following that, I think our next one after that might be the Coding Dojo, but we'll see from there. I have to look at JC's posts and Slack to keep up with the calendar. We definitely have tonight, and then the next one will be on this Saturday. That being said, we're not going to waste any more time. We are very grateful for all those who came up, as well as our featured speaker, a young man that I have known for a few years now. He has come around Code Connector for a few times in our in-person meetups. He's been to the GDG meetups here in the Memphis area, graduate of the Code Crew Code School that we all know and love, run by Meka Eguchekwe, and one of their, I guess, star graduates, I would say, because he's now a successful software engineer at Region 1 Health. So I'm going to let him introduce his topic and take things over. Everybody, please give a warm welcome to Juwan Moore.
Yes. Thank you for the intro, Lawrence. So kind of a quick intro. As Lawrence said, I'm Juwan Moore. I've been a software developer at Region 1 for it's getting close to about 3 years, slowly approaching 4. I'm a software developer under their innovation team and a very small team, but hopefully we'll get some more help soon. And I'm going to just jump right into my presentation. So let me get ready to share screen. Very quick. Okay. Screen. Okay, can everybody see my screen?
All good.
Fantastic. Okay. So the topic we're going to discuss is a pretty technical topic, I would say. And this topic will be on dependency injection and kind of understanding what it is and clearing up some other misconceptions or other related topics that go hand in hand with dependency injection. So we'll start off with what the definition of dependency injection. It is a technique or a strategy you can use to take a dependency from one class or object and transfer it to another class or object. And what's interesting about these dependencies are the dependencies aren't created inside of the class that depends on them. Rather, it's created outside. So I'll show you a quick example of what that looks like in code. So as you take a look at the left, so for example, on the left, let's say we have 2 classes, our school class and our teacher class. And our teacher class or rather our school class is going to be dependent upon our teacher class. So what this looks like without dependency injection is the school class will create a new instance of teacher. As opposed to when you're using dependency injection, that teacher dependency is given to the school, meaning the school class, once it's created, it doesn't go and create another teacher class. It just is already supplied with that teacher. And we'll go into a little more in depth as to how the school gets this teacher dependency without creating a new instance. But kind of just for now, just use your imagination for a second. Okay. So we're going to talk about some of the benefits of dependency injection. Those 5 key concepts being maintainability, readability, reusability, flexibility, and testability. So I'm going to, 1 second, I'm going to show you a quick example of what that looks like. I'm going to swap screens for a second. See. Okay, everybody can see my screen now? Great, great. Okay. So let's go actually over here. Oh, not that one. Not that one. There we go. Okay. So this is kind of the same example with the school teacher relationship being the school class is dependent upon the teacher class. And I'm going to show you kind of what that would look like if we weren't using dependency injection here to supply that teacher dependency. So I'm going to comment this out. And we're going to show you why it would be beneficial. Oh, I have a block of code here. Yeah. Okay, cool. So, okay, I think this is big enough. Okay. Okay, so let's say, for example, in our school teacher, our relationship, let's just say, for example, that our teacher class requires us, or teacher dependency in this case, requires us to have a name every time a teacher is created. So we'll just give this teacher constructor name. We'll say name is name. And the problem we run into here is with our current code example, this school class wouldn't be able to be created because teacher needs a name inside of its argument. So I'll do that real quick. Just put in a name. And this would solve our problem here. Yeah, so we don't have an error here. So the issue with that is, so to tackle upon kind of the maintainability, readability portions of it, or in fact, maintainability, readability, flexibility, and reusability. So those first 4 topics. So let's imagine if let's say that we need to constantly add new dependencies, or rather new requirements to our teacher class. So I'll just add H here. So this would mean that every time, let me actually change this name here. So that would mean that every time we make a change to our teacher class, or rather Yes. So anytime we need to make a change to our teacher class, we would also need to go inside of our school class here and make the according change as well. And that can make it, and that would mean that you would have to obviously write more code. So that tackles upon the readability, more lines of code, more difficult to understand what the code is. So I think it's running a little slow. It also tackles upon the maintainability portion of it, more so because, again, anytime you have to make changes to your teacher class, you'd have to do the same thing to your school class. And kind of to add on to that as well, let's say that you add in any solution you make, let's say that you add, a new dependency to your teacher class. Let's say, it needs a principal. Let's say, yeah, our school needs a principal, or, students, janitors. Anytime you need to make a change, you have in one place, you have to make a change anywhere else. As opposed to, say, if you use dependency injection, and I'm gonna show you what that looks like right here. Teacher. Yeah. So as opposed to using dependency injection, you would only need to make one change here. And this will work regardless of how many requirements you had to any of your teacher, principal, or any other dependencies needed for the school class. Yep, no errors. Okay. And look, we're gonna jump also into the testability side of it as well. So let me comment this out. Okay. So, let's save it. Let's save it. And oh, maybe where is it? 1 second. Where is? Oh, it's right here. Okay, I already had it. Okay, so as far as the testability is, we're gonna look at a unit test I've created to test to see if the functionality for our school class, particularly our, you go back to school. Particularly our Get Teacher class will return or rather, excuse me, our Get Teacher function will return the correct name for the teacher. So I'm gonna run this test right quick. See. Where is it? And this test should pass. Nope. Here we go. Let's run the test. Should run. It's still running. Yeah, the test is still running. Okay, it's passed. Okay, so let me explain what the test actually does as well. So inside of our unit test is going to inject a name of a teacher. So in this case, Sam, and create a new mock of our teacher right here. And it's going to set this name of the teacher to the name we just supplied here. So think of it as teacher name is going to be Sam. And our test function here actually simulates dependency injection where the school class will take this teacher dependency and then it'll run the get teacher class to verify that the expected result is going to equal Sam. And what we just saw with our test, it succeeded. So let's actually try to run this same test without dependency injection. So, comment this out. Let's go. One second. Okay. It's going pretty slow. One second. I'm gonna come at this this version of it and just use the one that wasn't using dependency injection. So I'm just gonna do I'm gonna take this out actually. Second. Okay. So in the unit test example we showed, well, the previous one, it injected the name Sam inside of the constructor for teacher. But in this case, since we're not using dependency injection, we're going to make up a new teacher and give it any name we want. Sure. We'll just say teacher equals Mark. Mark. It's going to be equals. Mark. Equals. Choose Mark. Let me see. Oh, here. Second. I think my IDE is running a little slow, so bear with me. Yeah. Okay. Okay, so my IDE is running a little slow, but for brevity's sake, this unit test would fail. More so because, let me go to my test. more so because in our example, 1 second. Yeah, so in this example here, since we name it Mark, there isn't an opportunity for us to change the name of our teacher to Sam in this case. And we could write some code here to say, well, school underscore teacher, that name is Mark. We could do that, and that unit test would work. The issue with that is that unit test wouldn't necessarily match the current solution that we have with school, where there isn't any place where we're changing that teacher's name. So that's kind of some of the benefits with dependency injection. And we're gonna move on to our next slide. So 1 second. Okay, everybody can see my PowerPoint? Okay, I'll take that as a yes. Okay, thanks. Okay. So here's a few of the different types of dependency injection that you can, or rather types or techniques you can use. So the one I've been showing you mostly is the constructor type, where we take the dependency and put it inside of the parameters here of whatever your class that requires a dependency. And this one's really useful if your dependency is where your class needs that dependency to function. Or if it's a case where you have multiple functions, say, I'll say maybe like 80–70% of your functions depend upon that dependency. So again, say school had 10 functions and 8 of them required teacher, that would be a good situation to use this constructor type. We also have the property type version of the property type technique to use dependency injection. So here we have a private and a teacher, well, a private and a public teacher property. The interesting thing to look at is the public teacher property, where in this case, it acts as a getter setter for the private teacher, meaning it gives us the opportunity to set the value to a private teacher. So in this case, for this example, if our teacher is null, meaning our school class doesn't have that dependency already supplied to it, the code will create a new teacher or a generic teacher for you. And for the property type dependency injection, this one's really useful if your dependency is optional, or if it's a case where I need to swap out my dependency once my class has already been, or once my parent class has already been created. And the final type of, oh, did I slow it? Okay, I think I skipped ahead. Okay, so the final type is the method type of dependency injection. And in this case, your function has the dependency inside of its parameters. And here you set the school property, or rather the teacher property here, to whatever was in your parameters. And this one's useful when you need to swap out your dependency multiple times, or if your implementation or your dependency needs to change every time that function is called. So we're going to go into a couple topics that are closely related to dependency injection, but are not necessarily dependency injection. So those two properties are called, or rather, those two topics are the dependency inversion principle and inversion of control. And we'll start off with the dependency inversion principle. So the dependency inversion principle, these were guidelines created by Uncle Bob, and they were geared towards making software easier to maintain and develop for object-oriented programming in general. And the dependency inversion principle, it represents the D inside of solid, and it states the following: high-level modules should not depend on low-level modules, both dependent on abstractions. Abstractions should not depend on details. Rather, details should depend on abstractions. So in layman's terms, a way you can think about it is all of us have iPhones and devices. And anytime you click an app on your device, it'll open up. What the abstraction talks about is we don't need to know all the code or the details behind what how the app opens. We do know that once we click the button on any app, it's gonna expand, it's gonna present you a certain screen, but we don't need to know exactly the nitty-gritty of how it's done. So that kind of speaks upon the abstractions should not depend on details. Now, as that goes with the high-level modules and low-level modules, a high-level module is supposed to depend upon an idea or something abstract. It doesn't need to know how, it doesn't need to know the how to do something. It just needs to know, I just need XYZ object. So kind of to go back with our phone example or app example, so if you click on an app, it just needs to know what app you're opening. It doesn't necessarily need to know what goes into the app or how your phone changes the background color of the app, depending on whatever settings you did to your phone. So that's kind of what the dependency inversion principle speaks upon. So I'm gonna present you with a use case of how we're gonna implement the dependency inversion principle with our kind of school teacher example that we have. So let's say that we have a school that depends upon three teacher objects. And each of these teacher objects are going to have different responsibilities. So in example one, we'll have a teacher that's going to teach 20 students. We'll have a second teacher object that will teach up to 40 students, but also be able to prepare students for the ACT. And a third teacher object that can teach up to 30 students and teach a speed class. Now, through the dependency inversion principle, I'll call it DIP for short. There's a way we can do that, and that's through interfaces. So think of interfaces, and interfaces speak upon the abstraction detail about the dependency inversion principle, where think of interfaces as contracts that lays out the functions that a class needs to have and what it needs to return, but it doesn't necessarily tell them how to go about doing that. So you look on the example in white, we have an interface, that's our, we have an iTeacher interface, and its only responsibility is to return a string. Once it has an int category. So we have three different examples: our school teacher, our ACT teacher, and our speed teacher, where it's using that interface, but it has its own. But each child class, being normal teacher, ACT teacher, speed teacher, they have their own implementation of how to use the teach class function. So kind of to solve our use case here, where we required our normal teacher to only teach up to 20 students, it has its own set of rules to check whether or not that student number reaches the threshold. So in this case, if it's under 0, it'll say you can't teach a class. If it's over 20, it'll tell you you have too many students, and otherwise it will tell you it's teaching. Ooh. I was about to sneeze. There it is. As I say. Yeah, so the else case, it'll tell you it's teaching whatever amount of students that was supplied to it. And the same thing can be said about the ACT teacher and the speed teacher as well, where it has its own thresholds to check how many students are in a class, and it'll tell you, and it'll return the string based on what number you put in there. So as I said, all these teachers have their own implementation of how to use the teach class, but all of them results with them returning the string, which meets the criteria of this interface. So we're going to take a look at what that looks like with how we're going to take a look at what dependency injection looks like with DIP and without DIP. So if we were trying to solve this solution with or without the dependency inversion principle, we would have to create 3, as you can look on our left, we'd have to create 3 separate functions to satisfy or to to satisfy the requirements. So one function specifically for the normal teacher, one specifically for the ACT, and one for the speed teacher. As opposed to if you did this with dependency injection, you have your iTeacher as your dependency, and you can use any variation of iTeacher. That variation being whether it's normal, ACT, teacher, whichever teacher you want to use, and all you need to do is run the teach class function, and it'll run that specific implementation of iTeacher. Another thing we can do with interfaces is we can also inherit from other interfaces. So to kind of meet the requirements for the prepping the teacher, prepping for the ACT and the speed class, we have 2 additional interfaces, respectively iACT and iSpeed, that inherit the iTeacher. So our ACT teacher will not only use the teach class from the iTeacher, but it'll also use, or to meet the requirements of the iACT interface, it will create a function to return a string that prepares students for the ACT. And the same thing can be said about the speed teacher as well. And with the dependency inversion principle, to meet those requirements, we would, instead of using iTeacher, we would use either iACT or iSpeed to use those classes. So here, iACT teacher is going to allows us to be able to call the school class, not the school class, but the class size function, and also the prep ACT function. And the same can be said with the speed teacher, or rather, excuse me, speed school implementation. Now we're going to jump into inversion of control. So inversion of control is a principle that converts control or responsibilities from one part of your program to another part of your program. And an easy way to look at it is a console application versus a web application. We have a console application. All of your code is just in one central file or an assortment of files, and your console will just run it kind of no problems. As opposed to, say, if you're building something more complicated like a web application, or specifically an MVC, where you have your model view controllers in all different places, your framework you're using will take responsibility of how to connect the dots. You'll still write the code for those specific functions, but your framework will kind of handle how it all fits together. And inversion control can branch off to different types of patterns and strategies you can use to fulfill its principle. And you take a look on our chart, one of those patterns you can use just happens to be dependency injection. So dependency injection is a pattern that you can use to fulfill inversion of control. Okay, so we're going to look at a couple examples of what inversion of control, or rather patterns of inversion of control, just to kind of get a better hang, so you guys can get a better understanding of what that can look like. So we'll start off with the factory pattern. So here, the main responsibility here is that we have this teacher factory class, and its sole responsibility is to create a new instance of teacher. So that allows our school class, anytime we create a new instance of school, our teacher factory will be responsible for creating that new instance of teacher. And here in this other example, we have the template pattern. And the template pattern, you could think of it as a way, or more so a skeleton, to run your other functions. So here we have inside of our abstract class, inside of abstract school specifically, we have a function called template method, and its responsibility is to call some of our abstract functions here. And the key part of where inversion of control comes in here is when we that's what I'm looking for. When we inherit from the abstract school class. So in this example here, we have, far ahead. We have our elementary school and our high school classes, and they inherit the abstract school class. So because of that, it will then allow us to, well, because it inherits from the abstract school, it requires us to use our add principal, add teacher, and add secretary functions. Now, where the magic comes in with the template pattern, is that these functions here, add principal, add teacher, add secretary, they're abstract. So that allows us to create our own implementation of how these functions operate. So here, add principal, add teacher, add secretary are different for the elementary school, and the add secretary, or rather, our principal, teacher, secretary classes are different, or their implementation are different between elementary school and high school. So when we run our template method here from inside of, so say we run our template method, or specifically if elementary school or high school runs that template method, it'll print out the results for add principal and add teacher, but their own separate implementations of it. Meaning, if we say elementary school call template method, it will just run these two, it'll run these two functions and return add elementary school principal, add elementary school teacher. Same thing with high school, our high school class, it would print add high school principal, add high school teacher. So we're going to kind of look into the magic as to kind of what I prefaced earlier as to how these classes get instantiated or created if you're using the dependency inversion principle. And you will use that through IOC containers or inversion control containers. And you can think of them as frameworks to create dependencies and inject them automatically when they're needed. So a couple of IOC containers you can use is Entity, AutoFast. If you're developing in .NET Core has its own IOC container built into it. So those are some of the few containers you can use. And when you're using an IOC container, it has a life cycle that we call the dependency injection life cycle. And it runs through 3 phases, being the release phase, the resolve phase, and the dispose phase. So the register phase is where we have the opportunity to map our dependencies, meaning, okay, I have this interface, what class or what object am I going to use to match with this interface? And second, you have the resolve step where it actually creates the dependency for you, kind of the shortest step. And you finally have the dispose step or the release step. And that step determines it determines whether or not how often you're creating a brand new instance of that dependency. So we're gonna kind of look at this example here on the right, where this one uses the Unity container framework as a IOC container. So in our first 2 steps, it registers the iTeacher, an iTeacher interface to a normal teacher, and it also does the same for ACT teacher as well. And in our second step, where it's going to register our school type, it's first going to resolve the it's first going to create a new it's going to resolve the iTeacher for normal and ACT, for normal and the normal teacher and ACT teacher, meaning it's creating that normal teacher class and ACT teacher class first. Then it's going to take that dependency and inject it into school. And then in this resolve step, it register it here for school. And in the resolve step, it actually does the creation of the normal teacher and ACT teacher here. So we're going to look into the dispose, or rather the release of the dependency injection lifecycle using Entity. Next page. Okay. So here, we have our container controlled lifecycle or lifetime. So in this lifetime here, it allows you to create it'll create a new instance of your object, and it's going to reuse the same instance anytime you resolve the dependency. So in this case, we register our teacher here, and then we say, okay, we're going to reuse the same instance over and over again with this container controlled lifestyle function. So every time we resolve it, so this is our first time resolving the school. And in this function here, this add desk is just going to add a new desk to the count. So the first time we resolve it, it's going to just add 1 desk to the count. But if we resolve it again, and by resolve it again, we're creating a new variable for it. And if we add a desk to this new variable, it still remembers the desk we put in this first normal, number 1. So it's going to add 1 plus 2 to that count. The second lifetime method that can be used is the hierarchical disposal type. And in this one, it'll create a new and separate instance for every child container. And each child container is going to reuse its own individual object upon subsequent resolutions. So in this example here, we register our iTeacher to our normal teacher, and we use the hierarchical lifetime manager, which will have every child have its own set individual instance. So here we're going to create the children here. Oh, sorry. Oops, I went back too far. Yeah, here we go. So we have child 1 and child number 2. We're registering them here, and then we're resolving them here. So we go through the code line by line. So this is for child number 1. We have our variable normal number 1, and when we resolve our child container the first time, it'll add a desk to it, to the count. So our count is 1. If we create a new variable for it, and if we still resolve that first child, it's still adding on to it, kind of like how we did in the previous example. However, for our other child number 2, it doesn't have any knowledge of what happened with child number 1. So it's going to start its own count from start. So here, normal number 3. So this is child number 2. We create a new instance of our school class, resolving it with child number 2. It adds a desk, and we make another variable for it with a 4th school instance inside using child number 2, and it still keeps track of child 2. So you can do this multiple times with multiple different children, and it's going to remember the count for that specific child class. And we're going to go into the final type of the disposal, and that is the transient method. And then this one is going to create a new instance anytime your object is resolved. So here in our example here, we register it, and we're using the transient version this time. And when we go to resolve or create our object, and then once we add a desk, it's every time we create a new, or every time we resolve, it's always going to start from 0, start at 1. Yes. And one other thing I was going to show you. So for any .NET developers, let's show it. Can you share screen one more time? Okay. Everybody can see Visual Studio? Okay, I'll take that as a yes. Okay. Yep. Thank you. So you're developing in .NET Core. You will use the, well, normally you'll use the built-in dependency, or rather the norm. Some people call it dependency injection container, IOC container. You'll hear that a few times. You'll use the built-in IOC container here under the configure services, and you would do your mapping here. Your mapping and resolving would all take place under this configure services inside of your startup class. And that's all I have to share for dependency injection. Are there any questions? I know this was a kind of really technical talk.
Fantastic job, Juwan. And let's give Juwan, let's give him a hand real quick. Silently or out loud, whatever you want to do. Appreciate that. Woo! Unlike you all, I was privileged to hear this lecture or this talk last month. He did such a good job. I invited him to come hang out with us here at Code Connector. So huge thanks to Juwan for doing that twice. As he said, now any questions, any thoughts you want to share or questions about the presentation today? DW, Richard, Jonathan, or JC? Now is the time.
I'm gonna go ahead and jump in. I do want to say I don't have any question for him, but just great job, just great talk, and thank you for stepping up and teaching us something. Thank you.
No problem.
This is a little bit off from your topic, but since there's no one else asking, I will ask this. You mentioned the template pattern, and I think you mentioned factory pattern. There's a few different design patterns, singleton, factory builder. Is that something you learned in code crew, those design patterns, or more so on the job, on your own? Where'd you get familiar with that? Or how did you get familiar with that?
Good question. So when I was doing my research upon that topic, and also kind of a little bit of professional development on my side, I was looking at different design patterns to see if there were any that I could use that was, or rather understanding different types of different design patterns. So if there's a use case I run into where I could use them, I could use those patterns. Those two stuck out specifically because I see there's a lot of documentation about those patterns specifically when it comes to inversion control.
Okay, cool. Thanks. Anyone else? All right, well, I'm not into begging. Well, we're going to again thank Juwan for coming out and hanging out with us here in Code Connector. Don't be a stranger, Juwan. Come back. We love you here. Fantastic talk on C#, dependency injection, and a whole bunch of OOP type stuff. So we really appreciate that. With that, we're going to go ahead and wrap up the night. Thank you all for coming out. Hope to see you soon.